Yeah, let's go then. First of all, thanks for inviting us. It'll be myself, Jorge, Arteiro, and Vic. Say hello, Vic.
Hello, guys.
Yeah, if you don't know me, I'm a cloud developer advocate working on the cloud native containers. Vic?
Yep, CSA, Microsoft in the ISV space / startups and application innovation. Based out in Melbourne. Some of you probably already know me and met in person. Look forward to coming back and chatting again about Container App.
That's great. Yeah, we're both from Microsoft. We're both based in Melbourne. I say that we're based on the internet now. And yeah, today let's talk about Azure Container Apps. I think someone put a challenging, is a real game changer or not. Let's discuss a little bit and let you guys to decide if it's a game changer or not. And first thing is the agenda. We're going to see a little bit what's like Cloud Native Compute Foundation is. Only because we are at Azure Container Apps using like two projects from CNCF. One is called Keda, that's an event-driven Autoscaling. Another one is DAPR, that's like application runtime for microservice, and you're going to see all the components that are on DAPR. We're not going like in too much detail, otherwise we have enough time for Vic to do the demos, but we're going to have some slides with some details and you're going to be clear how that thing works. And then you go on Azure Container Apps, overview, features, and go for demos with Vic. First thing, Vic is helping a lot as well. That's the community that we're building globally. As my position now as advocate, like not just for Australia, but for the whole world, and work a lot of Brazil with Australia, with people in US, some people in China, in Europe as well. And we have like 100 videos there now, probably 60 in English, 45 in, or like 55, 45 English and Portuguese at the moment. The Brazilian community is very strong, and they're producing a lot of content as well. There are videos with other cloud advocates from Microsoft, like talking about WebAssembly, for example. If you can follow us, we appreciate the support. Let's talk about CNCF. What's CNCF? And if you look on the CNCF.io, that's how they define what cloud native is. And Azure Container Apps is all about cloud native. And cloud native is all these, you can build scalable applications using modern dynamic environments, in public, private, or hybrid clouds using containers, service mesh, microservice, immutable infrastructure, declarative APIs. There are different ways to define that. That's the official, let's say. And you can go there on CNCF and understand all the ecosystem around the open source. I put some overview what the main projects are for CNCF. Means that CNCF is a foundation that was created for this kind of open source, not attached with any cloud or any supplier. And they created 3 levels, what they call graduated, incubated, and sandbox. Kubernetes is the main project. It was the project that pretty much created the whole thing. And there's some return. Okay. There's audio return. If you can put on mute there, I appreciate it. And the main project that we want to talk today is like Kubernetes, Helm, also Microsoft project. And on the incubating, we have like DAPR and Keda. Those are the 2 projects that we have on Azure Container Apps, and we're going to discuss. But Cloud Compute Foundation is a part of the Linux Foundation, and it was created exactly to integrate users, suppliers, and all the open source ecosystem around Cloud Native. And there's another project that I'm working personally, and if you want to help, is Brigade. that's like a async script framework for Kubernetes. That's another project I have been helping and be part of the team myself. Let's talk about Keda. Before we go for Azure Container Apps, let's understand what Azure Container Apps is using to create this serverless platform for containers. They're using something called Keda. Keda was an outscaling event-driven component on Kubernetes. Means that all that diagram that you see on the left here, on Azure Container Apps, you're going to see that you don't have to care. That's all managed by Azure Container Apps itself, and it's going to provide scaling based on event-driven. Now at the moment, they have 45 event-driven types available, not just for Azure things, like for open source projects, for other clouds. Means that you can use Keda on any Kubernetes cluster. Like if you're using something like Azure Arc, where you can onboard classes from other places, you still can use Keda. But on Azure Container Apps, you're going to see that's fully integrated, fully managed by the platform. You don't have to do anything, just use and consume. And the main difference would be you don't have to write YAML files for Kubernetes. You're just going to use the normal Azure CLI, the normal bicep or ARM templates, and Vic is going to show that. But keep in mind that you can scale your application now for, let's say, like a queue, a database, AWS queue, a Google queue, or like Apache Kafka, anything that can trigger your application to scale. For example, like HTTP add-on is one that's going to scale based on number of requests that you have concurrent for your application. If my API is getting too many requests, I start scaling, out-scaling my application. That's like a nice example. Or like a queue. If a queue is growing, you can scale your application. Vic is going to show that. And the other component is DAPR. DAPR is, that application runtime for distributed applications where it helps with the microservice thing. And you see, like in the blue box there, the dark blue box, the main, let's say, components of DAPR. Then DAPR is like I call that, providers or components, adapters. How do you call that? Like a library. That your application now, they don't have to write code now to talk with, for example, a state management, or how they're going to talk with a secret management like Key Vault or Vault from HashiCorp. We have Patrick here from HashiCorp on the call. Another thing is service discovery, service invocation. That's out of the box with DAPR as well. Another one, pub and sub. Let's go in details. I have some slides here showing details. Let's say service invocation. You can, when you call one service from the left here to the service one, your application calling service one, DAPR is always installing what they call the sidecar containers in your application, where they encapsulate all those features, all those components, and they can do things like MTLS for service-to-service communication. You can see at the bottom here, service discovery. They can even integrate with HashiCorp Vault or with Council or any external DNS. I think they have 3 options at the moment. But if the product that you are using is not there, you can even implement yourself. At the moment, it's Kubernetes, MDNS in Consul. And at the same time, they give out of the box like any other service mesh can do, but DAPR is not a service mesh. But they can also give all the metrics and logs and trace using App Insights. The nice thing of DAPR is if you want to swap from App Insights to like Jaeger or Zipkin or New Relic, you do just like that, and everything is going to the new provider. Means that you can have for one customer using App Insights, maybe for another one using Jaeger, or maybe in development in one way, in production a different way, if that's what you want. Or different applications using different providers there. Then all these logic to talk with those external components or DNS and is all encapsulated on DAPR itself. Your application, they don't have to know how to talk with those servers. The only thing they say is I want to log in and metrics and everything happen. See MTLS, there is certificates happening here. Another one is PubSub. PubSub is like a very popular service bus, Azure service bus, Redis cache, or anything that you want to use there. External ones, and say Kafka. And the same way, if you want to send a message, event, you just send. You don't even know if your application, your infra team decide to use service bus or something else. Everything is going to work. Your developers don't have to care about that anymore. Another one is secret management. Why I'm as a developer have to care if it's going to be stored on Key Vault or HashiCorp Vault is all encapsulated by DAPR, and at the deployment you can decide that. The same for state management. If I want to get an event and I just want to do like a post for a database, now I can without having to write this logic. It'll be all encapsulated by this component, and you can just send. There's some configuration that has to be done up front, but then you can also swap state management later on the deployment phase. But finally, let's go for the container apps itself. You understood that CNCF is like that bunch of open source projects all connected on the containers and microservices and Kubernetes, ecosystem. A lot of on the Linux ecosystem as well. And we have Azure Container or Azure Kubernetes Service, where you need more management of the environment. There are more operation for you to do it. Azure Container Apps is to be like a serverless. Is in public preview at the moment. It's not ready for production yet, but is a fully service where any framework, programming language, runtime will be compatible. How they do that? Using containers. Then if you can pack your application inside a container, you put inside like a container registry, could be Azure Container Registry, Docker Hub, or any private container registry, you're going to be able to deploy your application on Azure Container Apps. And there are like, let's say, 4 main components. That's Kubernetes itself, completely hidden. You don't have to care, you don't have to manage. You don't have access to the Kubernetes API, okay? I'm just telling you that's there, but you don't have to care. Envoy proxies used for ingress controllers, and then to get your internal or external traffic to the service, to the container apps itself, even to something like you call revisions as well. Revision is very similar to Azure App Service. If anyone here used Azure App Services lots before, where you can have multiple versions and you can split the traffic between versions, you're going to see that. And that's available on Azure Container Apps out of the box. And Keda DAPR, like we discussed, Keda is going to bring this Autoscaling, and DAPR is going to bring the microservice. Managing secrets is also encapsulated, like Kubernetes has some secret management. We're doing like a secret management. There's no integration with Key Vault yet, but Azure Key Vault, but maybe in a future will be there on the roadmap. And you have integration with GitHub for continuous deployment. Like I said, Autoscaling with Keda, microservice with DAPR, and everything now is using log analytics for the logs. Okay, I have 2 questions already. Before I go forward, let's see here. Any insights on VNet integration for the data will be available? Good news, VNet is available. I would say that's not like fully feature complete, but we can already connect your Azure Container Apps environment. That's the next thing I'm going to show here, but we get there, is there. Okay, Kevin saying 2 of my buddies already popping up in the comments. Yeah, yep, keep bringing comments and questions. Let's go now for the main use case for Azure Container Apps. I like to say that if you have like an API, because people are going to ask, why I need Azure Container Apps? Why I cannot use App Service or Azure Container Instance or Azure Functions? Yes, you can. You don't have to move your application here, but If your application is like an API with multiple instances that you need to scale, or you have a background processing that you need to scale based on like a queue or CPU and memory, or in really scale more than 2 instances, Azure Container Apps will be, cost effective, be faster than app service because it's like container, is a cloud native product, different from app service. If it's a single instance web application, probably app service you can keep there. But if you really need to scale there, container apps will be. And if you need to scale to 0, your applications will be able to not just scale up, but scale down to 0. And you cannot do that on the other service. Azure Functions you can. Probably you cannot do that on Azure Function Premium. But the main use case like APIs with HTTP requests, then you can scale by the number of requests concurrent. The background application, the event-driven and microservice, a lot of using DAPR and using Keda. Those are the 4 main use cases. I'm not going into details because Vic is going to show that. And those are the concepts. To create like a container apps, you create like an environment. Very similar to Azure App Service. I'm getting confused with the names, so many names now. Azure App Service. Good luck, Vic, showing the demos. But Azure App Service, you have what is called Azure App Service environment. The same thing here. We have the Azure Container Apps environment, where you can have multiple container apps. And why need that environment? On this environment is the place where we're going to answer the Shane question about the networking. We're going to connect this environment to a network, to a subnet, and we're going to give like a log analytics for this environment. Means that all the container apps installed inside this environment is like a group will be able to talk. The same for revisions. Each one of those applications, they can have different revisions, like slots. And they also can talk with each other. I think those are the main concepts. Before I go for the demos, is any question someone want to ask something? I think we're right on the time. Vic, still have time.
All right, no worries.
If someone want to get the microphone like for 2 or 3 minutes, and let's see, any questions on the VNet? I think we answered that already. Okay, if you don't have right now, we can leave for the questions for the end, Vic.
Okay, thanks,
Thank
George.
you. Let's go ahead.
Alrighty, cool. So let's get on with the demo. So just a quick note, because we're gonna cover quite a lot in here. We've pre-recorded these demos. I'm going to talk about it and just guide you through the process there. I can assure you though, it was done in a live environment, so no smoke and mirrors here. So this is going to be very close to a live demo. If you do have any questions, please just write them in the chat window, and we'll try to address it after the demo or live as well, if George kindly answers them, and whatever we can. And we also have a dedicated Q&A as well at the end, right? So cool. Let's get into it. So what I'm going to do, I'm going to start with the portal experience first, right? So again, just to really center or double down on one of the main goals for container apps is like what George says, is to reduce the barrier of entry for your team to take advantage of this great benefits of Kubernetes, such as autoscaling, self-healing, discovery, etc. Right? So what we're going to demo today is exactly that. We'll go through first with the basics of container apps and what it takes to build one, how simple and how easy that is. We then go ahead and try to incorporate and take it up a notch bit to deploy these resources into our CI/CD pipeline using GitHub Actions. So we'll demonstrate 2 use cases in here using basically showing or demonstrating that built-in DAPR and Keda. So let's get into it and take this thing for a quick spin. So first, portal experience, right? So I guess why we're doing it is just to convey, the ease and simplicity hosting your containers. If you just want to host containers kind of leveraging the AKS under the hood, right? But at the same time, you reduce its complexity, right? It's quite a big deal for some customers that don't have that in-house expertise. So we just simply need to go ahead and find container app there. It's currently in preview. We just create that, and we're going to name that demo AZ Nights or whatever. So I'm just going to fast forward that quickly. So we'll just name this container app as service app. And we'll also create the container app environment as well. So again, container app is that glue of log analytics as well as networking. So I think Shane asked about that networking integration. So this is where you actually configure if you want to, I guess, integrate your existing VNet. So at the moment, we've got 5 regions, as you can see there. We're expanding hopefully to more regions, and hopefully soon we'll be down under as well. We'll choose Canada Central for now. As you can see, if you try to create, you won't be able to create without log analytics. So we've sort of baked in the experience for you to, in order for basically for logging experience to view logging, you need to have log analytics. Although you can argue that this is not a mandatory kind of part of functioning of Azure Container App, we build that experience to ensure that we emit logs to a log analytics so that you can review it and queue it. In the future, it might change again. It's public preview, so at the moment, this is the only way for you to be able to view logs. Cool. So let's move on. Networking, again, I'll just quickly show that. This is basically the place where you can integrate your network again there. So I want demo here. So moving on, we will then be able to select our containers, right? So you can select a quick start image where you basically use the predefined or pre-selected quick start image, just hello world container. In this case, we can just demonstrate that you can use different registries, right? So you can use the ACR, you can use Docker Hub, or in this case, what we're going to use is the Microsoft Container Registry. So let's go ahead and do that. Just going to fast forward that quickly. Cool. And as you can see there, there's CPU and memory in there. So this is basically one of the components where there will be costs derived from, right? So our pricing is based on #1 requests. How many requests that you send through to container apps as well, or receive by container apps, as well as the resource, the seconds of that CPU and memory. Again, you can scale down to 0 as what George mentioned earlier. So here is you can use basically just ingress, build ingress using Envoy in the under covers. So as soon as you select that HTTP ingress set to enabled, it will be accessible from the internet, and you'll be able to access that. So again, I will fast forward that. So that will be completed soon. And here we should get our container app ready to go. Okay, so go to the resource. What we need to do is simply just copy that application URL, and we should be able to access that container app, right? So that's pretty much it. So it doesn't take a lot. It's very quick and simple, right, to basically do. And the great thing is, again, we leveraging the power of Kubernetes and the covers, as well as that built-in DAPR and Keda, which we're going to talk about as well. So if you were going to do this in Kubernetes, you have to build YAML manifests. You have to either deployment set, whatever. So, effectively making this a whole experience quite simple. Alrighty, so moving on, we're gonna take it up a notch a bit and go ahead and basically use or review the demo 2, which is looking at DAPR, right? So we're going to be leveraging DAPR in here. So what we're going to do here is to build 2 container apps integrating to a storage account, right? So we've got a a Python based container app that will generate some messages, and then we've got a Node based container app that will consume and persist those messages, right? And that will persist those messages in the storage account. So the client app, what it does is quite simple. It simply just sends an order number, and the service app will process that and store and persist that in a file in the with the order number in it in a block storage account. So what we'll see here is that with the, I guess, the power again of DAPR, we can easily build this app and integrate that persistent capability to Azure Blob Storage. The great thing is, you as a developer, you don't have to think a lot about, basically error handling, observability, retry management, and also security. Basically, like MTLS and all that stuff is being handled by DAPR. In real world, if you can sort of extrapolate this, there are many use cases where I'm just gonna post that. Where you, for example, you have a identity verification app where you have your, say, end users uploading their driver license or anything like for identity check. And as part of that identity verification, the app processes that and stores the verified image in a secure blob location. So what I'm going to do here is to review the code that I've created to basically list all the commands, right, that are required to deploy these resources. First, off the bat, you no longer interact with Kubernetes API, so you don't have access to that. All interaction is done by via Azure Resource Manager, via CLI. If you use IAC, Bicep, ARM templates, or APIs, etc. That is including leveraging various, DAPR, Keda functionality, which you don't need to kind of deploy and maintain manually if you are deployed in your Kubernetes clusters. So first, let's take a look at this command. So I've got a simple makefile in here. Just to simplify the build, I've created a makefile just to list out all the commands that we need to deploy those resources. Again, we've got the Python app and container and Node, and then we've got Azure Storage Account. So pretty self-explanatory, as you can see. First setup, you do need to install an extension for Azure CLI in order for you to be able to access that Azure Container app. And probably George is going to make an announcement as well about that. About there is a breaking change around that, which again we'll need to we can discuss that a bit later. So we have log analytics workspace. We've got container app environment. We've got storage account. Quite similar. The only difference here, as you can see here, I'm just post that, is that we going to use something, a program called environment substitution. So it's a Linux command, a program that really substitutes the values of those environment variables to make sure that we can replace the values within those parentheses. Those storage account container, storage account key, which we want to make sure that we don't actually check in the secret into our repo. Again, I've done that before, so show of hands if anyone already done that. Whether check in the certificates or whatever into repo. Being guilty here. Again, I'm not going to demo the use of this, but the idea here is that you can just go to terminal and type in make help right at the top there. I'm just gonna scroll up quickly. And effectively, it lists out all the command that you need to basically deploy container app and all the resources there. Again, you need to install this if you're running it for the first time. You need to install the extension. Cool. All right. Let's take a look how we can use Bicep and incorporate them into GitHub Actions, right? So we're going to do relatively the same thing, like what we did with the makefile approach, but we're going to do the whole process in GitHub Actions using CI/CD pipeline to deploy that. Again, for those of you who haven't tried Bicep, definitely encourage you to give that a go. Let me see what I have there. Cool. All right. So basically with this, I'm just going to go ahead and look at Bicep there. Right. just show of hands, anyone who have used Bicep. If anyone want to do that in Teams, and George, please give them on us. And you can imagine Bicep is like the next version of ARM template in a way, in that it's a much cleaner, much better experience that you'll be basically experiencing throughout building IEC in Azure. So pretty much like ARM template, you have parameters as well here. And I'm going to talk about target scope a little bit later. And also you have basically a resource. Basically, you deploy those resources there. So I've got a tag modules, bunch of modules. So these are the main concepts of Bicep. In that it's basically a way for you to interlock multiple resource deployments together. And we've broken down into various of following modules, right? So we've got create container environment, and we've got storage account, which will deploy the storage account. We also have the service app and the client app as well at the bottom of the module there in Bicep file. So again, it's basically just a way for us to deploy those various and break down all of those various components into basically a deployable resources. So going back to the target scope, if I just fast forward this one, and as you can see, we've got a target scope of subscription. The idea is that some most deployments typically target resource group, right? But you also have scenario where you want to target subscription, where you want to create resource group as well as part of that. So you can do that using that target scope subscription, and also you can target management group as well, and so on, right? So and tenant. So there you go. Just make sure that we got that clear. So I'm going to pause that for the moment. See if there's any questions so far on that. George, any questions so far? All good?
I think George has been answering them in the background, so all good.
I was on mute, sorry.
That's okay.
Yeah, all good.
Okay. Brilliant. Okay, so let's move on. Okay, so next I'm going to move on to GitHub Actions, right? So these are basically our CI/CD pipeline, and it's quite basic workflow that I have here. However, there's a couple of things worth mentioning, right? So we've defined some environment variables. So you remember that Bicep file which have all of those, Bicep file has those parameters. So we're going to be basically passing and providing that as environment variables in here in our GitHub Actions. Again, there's better ways to do it for sure. There are also GitHub Actions. So we've got 3 actions in here. So I've got checkout, I've got login, and I've got the CLI as well. So what it does is then deploy that Bicep files to basically resources in Azure. So once that's fully deployed, we can then navigate through the portal, similar experience again, and validate that as well. So let's do that. We'll need to kick off the GitHub Actions, as you can see here. So I have a trigger, obviously, to kick that off. We're able to see the GitHub Actions being triggered here as well. I'm just going to make some changes, and we'll do the same for basically both demos. So we're going to do it at the same time here. So let's fast forward that and just push those changes. So there's one demo 3. I'm going to push as well demo 3, so demo 2 as well changes. I'm going to make some quick changes there too. Cool. So that's there. And we should see demo 2 and demo 3 being deployed. Again, I haven't talked about demo 3. I'm going to explain that now. So with demo 3, what we have here is that we've got a container apps. It's just a single app, and we've got a basically storage queue. right? So we'll be leveraging the same concept. We'll be using bicep and GitHub Actions, as you can see there. And what we're doing here is that we'll be leveraging the built-in Keda functionality. So we'll be deploying an app that can pretty much scale the number of queues. Based on the number of queues, then it can scale and based on the Azure storage queue length. When there are no messages in the queue, the container app can then scale to 0 or 1, or pretty much whichever value that you set as the minimum replicas. There's similarities with the previous demo, but the key changes are that we're using storage queue and more importantly, take advantage of that built-in Keda functionality. So we're going to basically need to verify that our scale is actually working properly by simply pushing those messages to the queue and monitoring them as well. So let's do that. So our GitHub Actions completed, so that's done. So what we're going to do then, we just need to confirm and verify those changes in Azure Portal. Let's take a look at that. And then first, verify the demo to DAPR first, right? So DAPR demo. So let's just review that. Just open up the document again. Cool. And what we have here, just to refresh ourselves, so we've got a client will generate messages continuously, which will be passed to the service app, and then the service app then finally push that and create a file in a blob storage with the order ID in a blob. So let's take a look at that and make sure that we have that file containing that order ID in our containers in Azure Storage. Cool. So let's move on to storage count and then open up our containers. And within there, you see that we've got order file there. And what we need to do then, we need to go edit, and then we can see that order ID being updated every second or so, right? So we just click refresh and make sure that that integration is working. So pretty much with this, we know that our integration using DAPR is working. So you got that client app that generates that order ID and pass it on to that, and then go to storage account, and we've got that application effectively fully integrated using DAPR. So that concludes our second demo. So we then go ahead and have a look at demo 3, but I'm just going to pause quickly if there's any questions around that.
Yeah, I'm answering the questions here on the chat.
Fantastic.
Yeah, there is no volume on the service. It's not like a fully Kubernetes. If you need volume, probably AKS will be the solution. But you can use DAPR for state. More application state, different from like a disk or anything that you want to touch.
Yeah, so at this stage, stateless is what we're targeting, right? With container apps, any application that is stateless is something that we are targeting, but stateful is, it's potentially something that is more suited for AKS.
I think there is another question on ETA for GA and availability in Australia, if you guys know.
I don't have this information yet, maybe in a feature, but we're working. Probably next month, beginning of March, you're going to have more improvements like custom domains, improvements in networking, grass, and some integrations. But let's see it build if we can get something there, or a little bit after build, probably. But we don't have a date yet.
Cool. Alrighty, so let's move on with demo 3. So with demo 3 is the Keda functionality. So we're going to be looking at our query reader app, right? Again, just something that we just demonstrated and talk about. So this will scale based on number of messages that we have. Again, depending on the definition that you have on your bicep or CLI, whatever, as part of your deployment. In order for us to test it, effectively, we just need to put as much messages as we can, right, to that queue. So let's just go back there quickly, and want to make sure that container app can scale properly there. So I'm just gonna pause Apologies. So let's take a look at our deployment, right? So we have this effectively a queue, and we've got a container app, and we want to make sure that in order for us to scale, we need to push those queues and messages to that queue. All right. So let's have a look at our demo 3 application. So we've got this deployment that succeeded, and we'll then have a look at our queue reader app. And one way to basically check whether we've got how many replicas is to go to this. You can also do it in CLI. Go to revision management and then go to overview, and then you can see replica, number of replicas there. And pretty much what we need to do, we can just refresh this page and just have a look at number of replicas that are being provisioned, and then at the same time we need to have a look at the queue as well to make sure that we push as many messages as we can. So you can do it from the GUI, but it's just too cumbersome to do it, especially if you're trying to do it 100 messages to the queue. So what we're going to do, we'll push that using CLI, right? So the queue again is quite empty, and let's do that in CLI and just push messages in there. So I'm just going to have a look again, the queue, make sure that it's empty. Cool. And then I'll just run that again, the queues there. Cool. So in here, I will just push those messages right to the queue. Again, I got connection string, etc., which I ran previously, and make sure that we have those messages that are basically being stored in the queue, and that straight away the queue reader app will read that and dequeue those messages. And interestingly, it doesn't scale right away, right? And it comes down to how fast the the pod or the container app processes and reads those queues and effectively dequeuing them. Back to the number of CPU and RAM configuration. Obviously, the more messages that you push, the pod can only read so much at the same time while respecting the queue length that we set up. So effectively, the more messages and the lower length will increase the probability for our container app to scale out. Again, for demo purposes, we want to set it to low, but if you do it on in real world, you probably want to set it to high. I'm going to talk about that configuration quickly. So I'm just going to push more messages in here, and soon we'll see that our container app being scaled, right? So the replicas, as you can see there, it's set to 8, right? So it's pretty cool. So effectively, our scaler working perfectly, and that is really a good sign that it works. So let's take a look at how that is configured in Bicep, right? So if you were going to do this in, I don't know, Kubernetes, hosting it on yourself, like installing DAPR and Keda, that will just be quite a number of deployment that you have to go through. With this, it's as simple as in your deployment in Bicep, and we have a basically if I go to queue.bicep in there, you should see that obviously we've got that queue reader app. This is basically where we configure our container app as well as the scale rules, right? So we've got a scale rule there, as you can see. Minimum replicas of 1, maximum replicas of 10. Again, you can set it to 0, and the setting around queue length, basically under Azure queue there, is where we determine how fast things or how aggressive things need to be around scaling. So that is pretty much the beauty of having all of the DAPR and Keda fully baked into the platform, so that you don't have to go deal with those deployment manifests. So which is a lot easier. And again, that is it for the demo. Reflecting back on what we've gone through, right? So if you are going to achieve a similar effect in Kubernetes clusters, you'll have to first install DAPR. You have to install Keda as well in your cluster. Again, George mentioned about having, we've got an extension already around DAPR, and I think is that Keda as well, George? And you have to build separate deployment manifests to configure the scale rule. And also you have to maintain them all, where you can do all of these using Container App API, which are all built in, and you just need to feed the values. And it's all obviously serverless, which is sweet. Alrighty, that's it. Go back to you, George.
Yeah, and John just put a great question here, but thanks, Vic. Great presentation, great demo. And yeah, open for questions. Thank you everyone for watching and stay with us. We have like more than 30 people, and yeah, let's open for question.
I have
Questions?
disabled the unmute, so anybody can feel free to post something in the chat, or you can unmute yourself and ask questions. Up to you guys.
Yeah, there is one here from John Yu. If he's a real game changer, what do you think? I think there's another question related to that should be container apps like an option to move from AKS. I would say there is no one or another, it'll be always both. And to be honest, I see more container apps as the first step and AKS as the second one, not the other way around. I don't think you're going to move. If you're using AKS, I think you're probably going to keep using AKS. By the way, we have DAPR extension for AKS. And we're going to bring Keda. I'm working on the Keda extension. If you have any feedback on Keda, I'm working myself with the team with the product team on that. And we're also going to have those extensions installed on AKS. The difference will be AKS is a full package, full networking, full volume, full Kubernetes. You can do whatever you want. But we also bring those extensions on AKS that will be more flexible to operate. And I think, AKS is just growing to be like almost a fully managed service. But container apps is bringing those, Autoscaling and microservice thing. That's probably going to be the first option. If you need more than that, then you can go for AKS. But if you already have a team that understands AKS, just keep on AKS. I don't think you have to move to container apps. That's what do you think, Vic?